Now, how can we let the player of our game choose that initial max life here? For that, JavaScript has a nice little built-in function, so the browser has a nice little built-in function, I should say, and in JavaScript in the browser you can therefore use that, and that's the prompt function. It's a bit like alert, which shows a message dialog. This also shows a dialog, but it shows a dialog where the user may enter something. So here, first of all, we have some text which is displayed to the user. For example, maximum life for you and the monster, to tell the user what he should enter. And then you also can define an initial value, which should be a string. So for example, 100. Now if you save that and you reload this page, you're presented with this prompt where you can enter a value, for example, 70. Now if you hit OK, nothing happens right now because we're not doing anything with that entered value. The prompt function actually returns the value the user entered. So here I got my entered value constant, which holds that value the user chose here. Now that will be a string, not a number. That's important, but I want to have a number here to do my calculations correctly and not start concatenating strings or anything like that. So I want a number here, and therefore we should convert this to a number. Of course, you learned how that works. We can simply use parseInt, either wrap this right around this prompt function here, which would work, or for readability's sake, do it right here on chosen max life, where I then use parseInt on my entered value. So the entered value here, which is a string, is forwarded to parseInt. Now, of course, the user could have entered any kind of garbage here, for example, a string which is not convertible to a number. And therefore, here we can add a if check, and you can do that here as well, not just inside of functions, but also directly in the script, and check if the chosen max life here is maybe not a valid number. And for that, you can use a number function built into JavaScript, and that's the isNaN function, which checks if that is not a number. And parseInt will yield not a number, so this special NaN type, if you remember, if the value you pass to it, so entered value in this case, is something that can't be converted to a number. Then it will spit out NaN as a value, which is then stored in chosen max life. And with isNaN, we check if that's the case. So if chosen max life happens to be not a number, so this NaN special value. If that's the case, I'll set chosen max life to my default of 100, so that we still have a working value for the game. We then don't use what the user entered, because that was unusable. Instead, we use our default value here. I also want to step in if the user sets the life here to a negative value or to 0. So we'll add the OR operator here and check if chosen max life is smaller or equal than 0. That means that I also reset this to 100 if the user entered a too low life. Now, one important note regarding the order of evaluation here. JavaScript works such that it first checks this here if you have the OR operator. And if this yields true, since OR wants one of the two values to yield true overall, it doesn't even look at that second check here. So if we have chosen max life, which is not a number, it won't even try to do that comparison, which is great because for this comparison, we need chosen max life to be a number. But it will not even try to do that if this already tells us that it is not a number. So that's really good. It will stop for the OR operator after the first subcondition that returned true. If you had AND here, it would always look at both, because obviously for AND, both need to return true. But for OR, it stops after the first one that yielded true. So if we don't have a number with which we can work, it will not even try to do this check here. Now, in either case, we set chosen max life to 100, and therefore now we give the user a chance of initializing the values here. So if I save that and I reload, now we get that prompt, and if I enter 80 here, and I then inspect these health bars, you will see that indeed max and value is set to 80 here. If we now attack, you see this decreases to lower values, and at some point we won. Then we can start another new game and we won again because I'm spamming the strong attack. Obviously, this game is not really balanced. By spamming strong attack, you will very likely win every game. but it's more about practicing if statements than building the next best amazing game, which will win you tons of money. You will have to do that on your own, unfortunately. So that works. If I reload and I set a different value, like let's say 200, you see it takes 200 as a value here, and therefore, of course, the game takes way longer. The health bars take way longer to shrink. If I reload again and I set this to 5, obviously then one hit is enough to win. And if I set this to, let's say, -10, you said we end up with 100 because then we overwrite the user choice because of the invalid values here. Now, by the way, if we press cancel here, we also go with the default values because that also doesn't yield us a valid number in the end. So with that, we got these basics down. Now, there's certainly more we can tweak and more we will do in this section. For example, we're also not doing anything with the show log button because we're not writing a log at the moment. But the basic game logic is implemented, and we have a couple of examples for if checks, also with this special isNaN function here, and lots of combinations of conditions, lots of different checks.